Okay, so back to what we were doing. The applications to the human body. The circulatory, lots of applications, by the way, in fluid flow in the body. We're going to see it all over the human body. There's lots of fluids going on. There's lots of motion in the body, lots of applications of pressure. So it's a very important section for you to understand and grasp. And there will be just, there's some information I just want you to be able to give back to me, like the chambers of the heart and the fluid flow and the eye and just the different fluids that are at work. But I also want you to understand how these principles are being applied within the human body. So the circulatory system has two parts. This is probably something that you know. It has the systemic circuit and it has the pulmonary circuit. Be able to identify each of these, describe them. The systemic circuit takes blood to the body. So it goes from the heart out to the various parts of the body and then comes back again. The pulmonary circuit takes used blood. I'll put that in quotes. What I mean there is that the oxygen and various other things have been depleted out of the blood and passed on to the parts of the body. Uh, and then it returns that blood back to the lungs for replenishment. So if you're thinking about, here's your heart, here's the head. Those are supposed to be arms, and then these are legs. You get the idea. Uh, the systemic circuit will take blood and it'll go out into all these places, out into your arms, up into your head. The systemic circuit goes into lots of different places. The pulmonary circuit will take that blood and just go to your lungs. So it's a very short path for the pulmonary circuit. It just goes from your heart to your lungs and then back again. But the systemic circuit is actually quite long because it goes out to every part of the human body. Oh, we'll keep going. All right. So we will consider this system, the entire system, to be closed. That means that there's nothing coming in and nothing going out. That's sort of true. It's mostly true that there's nothing going in and nothing going out. So the flow rate is constant. Remember we were talking about pipes and we said that Q here has to equal Q here. And that's assuming that there's nothing coming in and there's nothing going out. And again, that's mostly true. It's not entirely true, but it's mostly true. So we can assume that the flow rate Q1 is equal to Q2. And also, since blood is viscous, the Boise equation also applies. For viscous flow, you need a continual drop in pressure. Remember that Poisson equation, that Q was equal to pi r to the fourth delta P, and that's what we're talking about here, that I have to have this drop in pressure in order for blood to flow is equal to 8 eta, and this is what is our viscosity, times the length of that circuit. I want you to know the order of blood flow. Actually, we'll stop there. I'll come back to it.